Find the period and sketch the graph of the equation y equals tangent of pi over 2x. Well, we have the tangent of pi over 2x can be written as the sine of pi over 2x divided by the cosine of pi over 2x. And what we know is we'll have vertical asymptotes anytime that the cosine of pi over 2x is 0. Well, the cosine is 0 at a couple of different angles. One time it's 0 is when we're looking at an angle of negative pi over 2 radians. That corresponds on the unit circle to an angle that opens downward. And of course, a point like this would have coordinates 0, comma y, or on a unit circle really 0, comma 1. Sorry, negative 1. And the fact that the x-coordinate is 0 means that the cosine is 0 there. So that gives us a 0 in the denominator and will give us a useful point for sketching the graph of our tangent. Likewise, an angle of pi over 2 will be useful. And if the argument of the cosine function pi over 2x, this argument, is between minus pi over 2 and pi over 2, that will give us a range of values for the argument that will produce one branch of the tangent curve. We know that the tangent curve spans the unshifted, untransformed tangent curve has a shape like this that spans the range from minus pi over 2 to pi over 2, where these vertical asymptotes are caused by the 0 in the denominator from the cosine. So what we'll do is we'll solve this inequality for x and find out the range of x values for the graph of this curve that will fall between the vertical asymptotes and produce one branch of this tangent curve. So let's divide everything by pi over 2. If we do that, we have negative 1 is less than x is less than positive 1. And so the curve that we're supposed to sketch, this would be y equals tangent of x, but we're supposed to sketch y equals tangent of pi over 2x. That curve has vertical asymptotes at negative 1 and at positive 1, but it will still have the same basic shape for a tangent curve, and that will repeat every 2 units. The distance from this vertical asymptote to this one is 2 units, as evidenced by the fact that that's from minus 1 to plus 1. If we go 2 units again, we'll be out to another vertical asymptote at 3, or if we go 2 units to the left, we'll have another vertical asymptote at negative 3, and another branch of cosine of the tangent will fall in between there. That's not a very good sketch though. Let me draw it better. It should have a 0 halfway in between those 2 vertical asymptotes, and I didn't have that before. So there's a decent sketch of 3 branches of the tangent curve that we were supposed to have. Notice that I've clearly labeled these vertical asymptotes as negative 1 and 1, or as clear as the pen will allow anyways. That's important for producing an accurate sketch for the curve. To find the period, we can just note that the difference between the 2 vertical asymptotes is 2 units, or we can always just take the period formula, which is pi divided by the value of b. b is pi over 2 in this case, and multiplying by the reciprocal for that fraction gives us pi times 2 over pi, or just 2, which is another way to see that the period is equal to 2 for this function.